Right. Good morning. Welcome back to Calculus 2. We are going to examine the series from n goes from 1 to infinity of x to the n divided by n to the n. We're going to see about how this works. So we have to figure out the radius of convergence on this one in the interval of convergence. So for this problem, what I'd like to do is I'd like to say, okay, how about we try I thought about trying the root test or the ratio test because that would give me an x to the n plus 1 over an n plus 1 raised to the n plus 1 over an x to the n over an n to the n. Now, there is something with this we could actually deal with, but you know what? Before we jump into this, because some stuff is going to cancel, we could get an x to the n here. We have an n plus 1 n plus 1 raised to the n. Here we have an n to the n, we have an x to the n. A lot of stuff is going to cancel out, okay? Which is kind of nice. But, we end up with 1 over x to the n, 1 over n plus 1, and then we'd have an n over n plus 1 raised to the nth power, which isn't going to help us too much. Instead of using the ratio test, how about we try the root test on this one? Okay, and see if that works. So what I'm going to do is I'm going to say, can we take the nth root of the absolute value of, let's see here, we have x to the n over n to the n. Okay, and then figure out, we'll keep that in absolute values there. It's terrible, but we'll go ahead and we'll deal with it that way. So we have an n, the nth root of x to the n over n, and this turns into just x over n. Okay, now remember the root test is going to say something like, well, what if my limit as n goes to infinity is equal to 0? Then this test will be okay. So if it equals 1, then not so good. Okay, but if we are going to be able to equal 0, then we're going to be able to say converges. Okay, so as I'm looking at this limit, as n goes off to infinity of x over n, as long as x is a bounded number, like as long as x isn't infinity, this is going to work out just fine. So we can't really say that we set x equal to infinity. It's not a value. I know that in calculus one we tend to treat it like a value, but it's one of those things like don't treat infinity like a number. Don't treat it like we can plug it in and get a value out of it or anything like that. So this is going to go to 0 for any value of x that we could pick. So in this case, my interval of convergence is going to be negative infinity. Don't put the sign x greater than that. So we're just going to be able to say my interval is going to be negative infinity up to positive infinity. So x could be any number. So the radius convergence for this problem is infinite. Pick any x you'd like, and it'll converge. Okay, which is kind of an interesting problem. We don't have to worry about the boundary because even though I kind of wrote it, it's not. You're never going to be equal to infinity. It's just not a thing that's going to happen. Okay, you can't do that. So for this one, it's a little bit refreshing. I was like, okay, we don't have to pay attention to the endpoints, and a rare case where the root test was actually the right test to go deal with. I'm going to say thank you very much for watching the video. I'll see you in the next one. Take care until then.